Okay, we got to get through 2 more things. 2 more things. So hopefully I can do that in 10 minutes. I think I can. Sex limited inheritance. These are affected by gender because, again, you can't have a uterus, so it doesn't affect you. Or these are patterns of gene expressions that are affected by gender, even though they're not on the X chromosome. Okay, so they're not X chromosome. You can only have them if you are a specific gender. One of the examples, well, especially things that are related to hormones that men or women have more of. But also domestic fowl neck plumage. That's what you were going to say. You're like, you know what? I think that's chicken plumage. I know that's not what you were going to say, but feather plumage in chickens. It's caused by an autosomal gene. Hen feathers, that's the girl, are controlled by a dominant allele. Cock feathers, that's a boy, are controlled by recessive alleles and only expressed in males. So basically, if you're HH and you're a girl, you have hen feathers. If you're HH and you're a boy, you still have hen feathers. If you're heterozygous and you're a girl, hen feathers. Heterozygous boy, also hen feathers. Whoops, and I feel like this should be a little h. You're hen feathered. If you're little h, you have cock feathers. So you can have the dominant, homozygous recessive, and it only affects you if you are a male chicken. I like that. The hen feather is on the left, cock feathering on the right. Note that the hen's feathers are shorter and less curved. So you want the, I don't know what is like the best in chickens. I don't know. Like, I'm not a chicken breeder, so I don't know. This actual chicken looks pretty cool, but whatever. Male pattern baldness. Sex influenced, again, because it is, it just looks different in men. They actually get bald. It is a sex influence trait. So you have to be a boy. You have to be a man to have that expressed in a particular way. Phenotypic expression of traits, sometimes influenced by the environment. So sometimes we can mess with that and put them things in higher densities or in colder temperatures, and they phenotypically express differently. It's influenced by genotype and the environment, and the gene produces function within a cell in various ways, and the organism exists in diverse environmental influences. So, penetrance versus expressivity. Penetrance, percentage of expression of the mutant genotype in the population. So, a great example for me recently is like autism, right? You have people who are just like, oh yeah, I'm autistic, it's bad. But they're like, you wouldn't know that unless they told you. And then you have people who like are nonverbal. So there's like, it's a spectrum. It's a wide. So penetrance is the percentage of the expression of the mutant genotype in the population. So this is like, you have the gene, but it doesn't express all the time. So this would be more like breast cancer, right? Expressivity is like autism, right? Penetrance is the percent of the expression in the overall population. Expressivity is the range of expression of the mutant phenotype. This is also like the BRCA gene. You can have the BRCA gene and not even ever get breast cancer. So there's a range of expression. Penetrance is how much of the population does it affect. Okay, so those, I will just ask you a multiple choice and you have the answer right there. I'm not going to ask you any other time. There's an eyeless mutation in Drosophila. The phenotypic ranges from presence of a normal eye to an absence of both eyes. It's real creepy. So this is an eyeless fly. Very disturbing. It is variably expressed. So all 3 of these flies have the same genes, and one has no eyes, one has like little mutant tiny eyes, and one has normal eyes. So this is like a graduation in the phenotype range from wild type to partial reduction in eyeless. So it's like variably expressed. Okay, let's talk about temperature because I think this one's really cool. So evening primrose, cut-leaf evening primrose, it's a plant. It has red flowers if it's grown at 23 degrees Celsius, and it has white flowers if it's grown at 18 degrees Celsius. Siamese cats and Himalayan rabbits. Darker fur color on cooler areas of the body. feet, tail, and ears. The enzyme loses its catalytic or enzyme function or ability to create a reaction that creates color at higher temperatures. So if you keep it cool, it stays white. So here's the example. Here's a Himalayan rabbit that has been kept cool and it has not been able to make the protein for color as it was developing. And here's a Siamese cat. Both show dark fur color in the snot, ears, and paws area. The patches are due to the temperature-sensitive allele response for pigment production. There's also temperature-sensitive mutants in Drosophila viruses and bacteria. They will just only express when you have a certain also environmental condition. You could say this about many other things. We've got Tay-Sachs disease. We already talked about this. Newborn is normal for a few months, then can develop a disability, paralysis, blindness, and death by age 3. Sometimes Lesnai disease, due to the gene encoding the enzyme HGPRT, newborns are normal for 6 to 8 months prior to onset of the first symptoms. So sometimes it's just, again, we had talked about Huntington's. It's a dominant disease, so you have it, you carry it with you, you don't know, you pass it on to your offspring, you don't really realize you have it until you're about 45, and then you have brain deterioration accompanied by spastic uncontrollable movements, intellectual and emotional deterioration, and ultimately death, right soon around the age of 45. Okay, and I think that is all we really need to talk about for this one. Okay, that should give you all the definitions you need for this chapter's multiple choice test.